Hi everybody, my name is Daniel Murphy. I'm Head of Site Reliability Engineering at PwC UK, and this is actually my second year doing this conference, so thank you very much for having me back. And it's great to actually have three people from Northern Ireland speaking at today's conference, so it really shows that all-Ireland nature which Google is embracing. So thank you all very much for that. My talk today is all about AI. I know there's been a lot of talk about AI, and that's all really AI is at the minute. It's all talk. I want to get down to the nitty-gritty and show how it's actually being used in incident management. This is all based on events and things that have happened and all the different things I've done over the last 12 months. So let's get into it. Today, I want to briefly touch on 4 topics. So I want to talk to you about the problem we're trying to solve. Then we're going to talk about the 4 implementation layers of incident management. If anybody here is ITIL certified, you're probably thinking to yourself, there's not 4 layers, there's only 2. Well, unfortunately, AI has actually turned that into 4 layers. I want to talk about the role of the solo engineer because it has changed a lot since the introduction of AI. And then lastly but not least, I want to give you a little example, bring it to life, and talk about how you can implement that in your own organization. So the problem. Anybody here that is on call or responsible for a service or a website or anything is going to get absolutely bombarded with alerts or triages or incidents. And it's a lot. And it's a lot that can happen at any time of day or night as well. This world is 24/7. Unfortunately. What happens then is context switching. So if anybody follows the philosophy of focus, flow and joy, if you're trying to focus on one thing and you're getting pinged left, right and centre, you're never truly focusing on one thing. One eye is always on the other screen. But there's big opportunity here using AI. And the main opportunity for me as an SRE engineer is MTTR and NTTA. And it's about working on those metrics and getting to as close to the 100% holy grail as we can achieve. And finally, but not least, we're looking to move to reactive instead of being, we're looking to move to being proactive instead of being reactive. Instead of waiting for things to happen, waiting for things to blow up and go on fire, we're trying to predict them ahead of time and fix them before they're ever issues. I want to briefly touch on the 7 key principles of SRE. Is everybody acutely familiar with this? Yeah? Everybody loves SRE and is fully embraced to its philosophy and principles. The SRE principles haven't really changed in the last 20 years, but they are so well adapted to AI that it's almost like they predicted it ahead of time. Embracing risk. Implementing AI in your organization is a big risk. You're essentially giving something which is not fully quantifiable or controlled full access to literally everything in your organization as well. It's also built by third-party companies which, sometimes they have their own agendas coming along the line. It's also changing all the time. There's new versions and new models happening all the time then as well. So if you do bring in AI, it's only as good of that model. It's going to change that. So, security and governance, those kind of people, they absolutely hate AI. I work for PwC. We have maybe 4,000 people working in a department called risk. Literally just risk. And that's all they do is analyze risk for people. If we've managed to implement AI into everything that we do, you can too. Secondly, SLAs, SLOs. So if you implement AI in your organization, you need to see that it's actually doing what you want it to do. So if you implement AI and your SLOs and SLAs haven't changed or they've changed going the opposite direction, there's an issue there then as well. Automation and toil are 2 of the main areas that everybody is focused on AI at the minute. It's all this talk about, getting AI to do all the mundane, repetitive jobs so that human engineers don't have to do them then as well. Works perfectly with SRE philosophies. Monitoring distribution systems, a bit like SLAs, SLOs. If you build it, you have to monitor it, you have to quantify it. You actually see it's doing what you want it to do then as well. Release engineering, the modern cloud is all code-based, all your infrastructure is code-based, and all software is code-based then as well. Why shouldn't your AI be code-based then as well? Why can't it be controlled using the same GitHub repositories that everything else is done? And so that's what we're trying to do. We're essentially trying to fold it into the same software development practices that should already exist in your organization. And last but not least, simplicity. AI is anything but simple, but we always try to use that term simply brilliant. Just because something is complicated doesn't mean it's any good. It needs to be understood by as many people in the organization as possible, so you're always trying to build the most simple system that does the most complicated thing for you. Now, I want to briefly touch on the term force multiplication because it's a bit of an odd term, and I chose it specifically because we're not adding anything here. Your engineering team's not going to get any bigger because of AI. In fact, it's probably going to get smaller. So it's about using tools to make people more effective in what they're doing then as well. Can anybody tell me who that quote is from? Archimedes? Oh, you're close. It's actually Pedro Pascal in Fantastic Four. That's a good shout. To bring this to life, I want to use the example of a soldier. If you give a soldier a pair of night vision goggles, he's still the same soldier. He's not going to run any faster, he's not going to jump any higher, but he is going to be infinitely better at murdering people at night time. Essentially, you're giving a tool to somebody to do what they currently do in a better way. And that's what we're trying to do with AI. Not murder people, but make everybody more efficient. Now, the first layer of in incident management is triage. Basically, something happened. An event has occurred within your organization. And this information can get to you in a number of different ways. It can be your CTO going and tapping you on the shoulder saying the website's down. It can be PagerDuty giving you a phone call in the middle of the night. Whatever it is, first stage is always triage. So things come in the door and they have to be quantified. And the first thing that you're probably going to do is fingerprint it, see if this is unique or if this is something we've seen before, it's not to worry about. There's probably an element of deduplication there. Sometimes you can receive 50 alerts for the one thing then as well. And the last thing then as well, you have to give it a priority weighting then as well. Is this a P1? Is the whole place on fire? Or is this a P3? We'll get to this on Monday whenever we get back into the office. Straight away, AI is in its element here. Deduplication. So you have logic built into your service now, whatever ticket management platform, to say you have received 50 tickets in the last 2 minutes, all about the same things. It gives you one ticket then as well. So an engineer doesn't have to wade through 50 tickets and link them all together and make them parent and child to each other. So straight away, it saves you about 20 minutes of work then. Next thing then is uniqueness. Is this unique or have we seen this thing in the past? So if there's a recurring error code, it can automatically pull up, oh, we've seen this yesterday, this is the context for that then as well. So you're straight away linking things together that an engineer would have figured out eventually. If it's maybe a large engineering team, it would have taken even longer. If it's a small team, you were involved in that event the previous day. And last but not least, the prioritization. So, applying that P1, 2, 3 severity to something. AI should be directly linked into your monitoring platform. So if it's, Datadog or New Radical, those kind of ones. If you're running an e-commerce website and the site is down for longer than 60 seconds, well, that should trigger a P1. And if a P1 is triggered, there should be a runbook that follows directly after that. In a lot of our situations, a war room is declared, there is a group of people need to get notified, and essentially you're sort of circling the wagons to say something big is going on, get everybody together. That can all be automated using AI. So all you're doing is actually call it to need, or you're still in the room. MCP server directly connecting to your email system then as well, a predefined group of people, off it goes. So straight away, an event has occurred, it's been triaged by the AI, and the correct people have been notified. And it'll do that within a couple of seconds. A human will do that, it'll just take a bit longer. The next layer is contextual assembly then as well. And AI is really starting to get into its own at this stage then as well. So it's tied into a lot of your systems then as well. So your CRM system, any ticketing system then as well, your Jira, your Confluence, your Slack, your Teams, whatever it is, it doesn't matter. AI and MCP should be able to talk to everything and anything. And at this stage, it's going to start being more proactive and actually giving you a lot more information that you probably previously wouldn't be aware of. If you look at something like ServiceNow, there's a search functionality within it. And the search functionality is like the same search functionality you get in Outlook. It's terrible. Anything that isn't exactly case matched, it's never going to find. But LLMs actually excel at anything that is text-based, and they really come into their own when it comes to this kind of situation then as well. So if something occurs and you search for it inside your ServiceNow, but it's not exactly the same, it's going to give you sort of contextually matched cases that I've experienced in the past. Diffing then as well is another fantastic one it can do. So diffing essentially is taking two configuration files or two pieces of code and telling you the differences between them as well. So your AI should be tied into your software development pipeline as well. It should show you, okay, an event occurred at 12:40, but there was a deployment at 12 o'clock. There's causality there then as well. So it should be acutely aware of the last time software deployment was done. And so we can show you, this may be the issue, but you should probably have a look at it then as well. If it is a code thing, diffing is absolutely perfect with this. Please compare these two different files. What's the difference in them? That's something that an engineer can do, but if you read through hundreds of lines of code, it's going to take time. An LLM is acutely aware of these kind of things and can tell you that within a second or two. Now, what else can it do? Well, it can start kicking off automatic workflows for you then as well. If you are in a kind of environment where things reoccur all the time and there's previously built runbooks to sort out these lot of things, it can start kicking these off for you. A bit of a human in the loop. This has occurred, we've seen in the past, this was the resolution for it then as well. So it suggests the fix for you, and then a human can say, yes, I'm aware, that's the fix, please execute that fix on my behalf. Then moves to the third layer, and this is where things really come into their own. This is where an AI layer has been implemented across all your incident management platforms. In the AI layer, you train a RAG model on you, your company information, and everything you and your company does. So it's tied into your Confluence, your Jira, your ServiceNow, all your document store, everything the company is aware of. And it's familiar with all of it, but it's not connected to the internet. That's a very crucial part. So any answer it's going to give you is based solely on the context of your organization. You can put a gate in later on, or maybe it's failing to give you the resolution, and you can say, okay, go search the internet for this then as well. But it's crucial that this stage then is not internet facing. It's been trained on every past incident that you have ever occurred in your organization then as well. And in this layer, it's starting to do a lot more things for you. So we're moving really into the agentic phase here as well. In the past, you would have kicked off automatic runbooks, but now you're starting to reach out to more things that were done previously. In this layer, you're starting to take in things that it wouldn't have done in the past. If you do need to go to like a graceful shutdown of your core services, maybe a P1 incident has occurred, a database has fallen over, it needs to get folded over a different database. It is acutely aware of your infrastructure, and it can actually start moving users from one load balancer to another while kicking off a graceful degradation script down as well. That could include communications that might go out to your customers, bringing up a temporary page down as well, saying, uh-oh, there's been a problem, please bear with us down as well. So it's taken away a lot of the heavy lifting that a third level engineer would have done. At this stage, we're still talking about level 1 engineer. We're talking about service desk engineers who are now carrying out the tasks that a second or third line engineer would have in the past. So what we're trying to do here is do the most with the engineers that we have instead of passing it up the chain. And as you pass up the chain, you're using more expensive engineers, you're using more time-consuming engineers then as well. So at this stage, if you can get your level 1 engineering team using AI tools, it's going to make it vastly more cost-effective and efficient as a system. The last layer then is the orchestration layer then as well. I'm firmly of the opinion that if you build it, you own it, you maintain it. That's when it comes to software delivery, that's when it comes to infrastructure delivery. That is my personal philosophy then as well. Software developers should be absolutely included into postmortems, incident management, and they should be on call. Long were the days whenever DevOps wasn't a thing and people could build things, throw it over the fence and forget about it and let somebody else worry about it. Now in the era of AI, if you build an AI agent or an AI tool that's going to help you and your organization, you're going to have to own it then as well. So everybody is going to become an AI orchestrator then as well. And I mean everybody. It's not just going to be an issue for the SRE engineering team then as well. So if a development team builds something that's going to help them with their jobs, they're going to be responsible for maintaining it then as well. So everybody is going to become an AI orchestrator. I'm already starting to see a lot of jobs going up saying, AI engineer, AI this, ML ops that then as well. It's already moving into sketchy territory where essentially you're giving all your AI tools for one person to be a responsible owner for them. It might sound like a good idea, it might sound like you're shifting responsibility, but at the same time, when you shift responsibility, you shift accountability then as well. So if you build it, you own it. That's my philosophy, and that's the fourth level of orchestration. And this is something that's probably going to go along with your day-to-day job then as well. Unless your organization is absolutely massive and you can make this into your own full-time jobs building AI tools, but you're also going to maintain them tools. This feeds nicely into the next topic, the solo engineer. Now, I'm from the SRE school of thought where I like to run the pod system. A pod system, in a nutshell, is 3 to 5 team members all working together on one thing. Different skill sets, different range of seniority then as well. And it makes these lovely little sort of feedback loops with the senior engineers are training the junior engineers. You have pair coding going on then as well. And you get so much work done when you work like that together. It's a collaboration space where it's safe. The likelihood of making a mistake or deploying something wrong is extremely low because you have that sort of senior leadership and technical knowledge there as well. AI has kind of messed that structure up a little bit. You're starting to see now a junior engineer with agentic AI tools doing the same work of a senior engineer would have in the past. So instead of 3 to 5 people working together on things, you're starting to see individuals working on things and then going to the senior engineer at the last stage. Can you suddenly check this? Can you double check this before I do this? And the tools behind that, you know yourself. It's Swinsurf, it's Cursor, it's Code Whisperer then as well. It depends on your software stack and whatever you're running with in your organization then as well. But ideally, you're starting to see people coding in languages now they wouldn't have even bothered with. As an SRE engineer, I dabble in Python. I can understand a bit of Java, but if you give Cobalt or Basic to me, I'm sorry, you might as well be speaking French. But if I'm given a problem where I need to tweak a few lines of a bit of code that I don't know, you can put that in a cursor, and you're going to get 99% of the way there. Put it into a test environment, see if it's working, and me, not knowing the language at all, can now do things in a language which was complete gibberish to me. So you're starting to see people not having to go to software development teams or those kind of language experts to do things in these different languages then as well. Now, I want to bring this, bring it to life a little bit because, you know, a lot of it's talk. This is an AWS example. Please don't be intimidated by that. The company names and everything within this have all been blanked out as well. This is just a really bad drawing of what their infrastructure was. So it was an American healthcare provider that took information from hospitals all over America. And this information went back to their central location and it was analysed and then given back to the customers in dashboards and sort of online format as well. And the information came in VPN tunnels. And if anybody here is over the age of 35 and has experienced physical VPNs, you're going to start realising that managing hundreds of VPN is an absolute nightmare. Not only that, you're probably dealing with 5 or 6 different vendors, and you're probably talking about 5 or 6 different versions with each one of those 5 or 6 different versions then as well. So this was an absolute mess. The first engineer in the morning at 8 o'clock would have to check the tunnels, and you're talking about 150 tunnels here, and you're trying to check that they're up or they're down then as well. And every day you're probably talking 30 or 40 tunnels are not responding. So the engineer, the first guy in the door, would start cycling these tunnels, would start to send commands to each one of them in different languages and in different versions and logging into different portals to try to get all these tunnels back up. Came to about 10 o'clock in the morning and his big list was down to a smaller list. So he's maybe working with 10 or 15 tunnels now then as well. And that's when you start ringing people and start sending emails to all these different hospitals all over the US that all work in different time zones and people go on holidays, the IT team's going to be different on a daily basis then as well. And I'm trying to get them, okay, tunnel's down, can you restart your side? I'll restart my side, is it working? Until eventually you got to midday and you got to the very small list of which tunnels were actually the problem ones for the day. And then, you did on your best, send emails around them every you could, and you went back to your day job. That was half a day's engineering time, every day, 7 days a week. Now, I'm actually a little ashamed to admit that this took so long to actually have somebody look at it and automate this. So we decided, right, there needs to be a calculation done here. We want to automate this tunnel process then as well and bringing these back online if there is a failure along the way. But there's so many different languages in play. How are we going to do this? And the calculation was basic. It was quite simple when you think about it. How much time do we think it's going to take to fix this compared to how much time will it save us over the course of a year then as well? And if those two figures are vastly different, then absolutely go for it. And in this case it was half a day's engineering time, 365 days a year, is probably in the hundreds of thousands. In the end, it took about 2 weeks of 2 engineers part-time to fix this problem. And what they done was very simple. They built a very simple workflow. They incorporated all the different languages for all the different VPN tunnels got to the point where it was just solid logic. If there's been no response within 3 periods of 15 minutes, cycle the tunnel. If that doesn't work and there's been no response within 3 periods of that, 3 15-minute cycles then as well, reset the tunnel completely. If that fails after 3 attempts then as well, send an email to this list of engineers that we had on the opposite side then as well. So once this was implemented, the first engineer to come in the door, essentially he had the list that he would have had at 12 o'clock on the day. So he knows who the problem childs are for the day, and he can just start targeting them and ringing people directly. Half a day's engineer time saved with maybe 2 weeks' work. So you start to see how AI can really start helping engineers fix things that should have been fixed a long time ago. Now, implementing this into your organization, it's difficult. I'm not going to lie. PwC is a massive organisation and we implement it for our customers. And our customers are typically banks, building societies, military contractors, even the government then as well. And every one of these organisations is the same. They're a giant pyramid. We have the engineers on the bottom level, then we have a middle layer of management, depending on the size of the organisation. They could be semi-technical, they could be hands-on, if they're a startup. And then you have the very top of the pyramid with your CTOs and your CEOs then as well. And depending on who wants to implement this or what the level of appetite is, you're going to have a different experience along the way. Implementing it at the engineer level, so us trying to bring something to the table and say, I want to bring in Code Whisperer and this is what we're going to use to do everything going forward. And you're trying to convince your fellow engineers, and then you have to convince your management team, and then your management team has to convince your CTO. That is by far the hardest way to do it. Second one then is the management layer, the middle management layer, trying to bring it into your organisation. Now, at least in this organisation, at this level, you have some kind of sway and some kind of pull. And you can put together a business case saying, if we spend a couple of $100,000 on this, it's going to save us X amount of pounds over the course of the year. Sorry, euros. And then the last way is the CTO-led, and it is by far the easiest. Make a decision, invest in it, it's going to happen. It'll trickle down along the way, and it will get done. So there's a rough blueprint, and this is something I've done in the past when it comes to, actually, I've done this when implementing observability into your organization. So if you want to bring in a unified monitoring platform, implementing AI is much the same way. You need to pick something that is going to improve. Look through your ticket queue and see what the most common reoccurring issue is, or see what the most time-consuming issue is then as well, and pick that one. It then needs to be measurable. So, this has occurred 100 times in the past year, and it's cost us X amount of time to fix this thing as well. So you need to pick something that's measurable. You need to show something that's going to show some real value then as well. And you need something that's achievable. If you pick something that's going to take 6 months and 2 or 3 engineers full time, and at the end of it, is it going to have a net benefit to you? I don't know. You need to spend something with the greatest bang for your buck, or what's going to take least amount of time, but it will have the most real world impact. Create an MVP, run it for a few weeks, and then you start circling it around your organization. You maybe get a friendly manager and you show them, look what we've done. We've implemented this. We've gone a bit rogue, done it ourselves, but look it's starting to show value. At this stage then, it whets his appetite. Managers love nothing more than taking credit for somebody else's work. I know. So once they're on board, you need to shift left then as well. You need to go back and get the security team included, and that can be the most painfully brutal thing we're trying to do here. Security needs to get involved as early on as possible, because the last thing you want to do is get something ready for production and then it just gets blocked by security. So you need to shift left fairly early on and get them on board then as well. And say, like, what we're trying to build here will work in the real world. We've gone through all the proper architecture and security reviews then as well. Here it is. And once you have all that there, that's when you start bringing it up to the CTO, and that's when you start circulating around your organization saying, look what we've done. We've made this thing. This is how good it's become. And then finally, but not least, if you take it to your platform team or you take it to your organizational-wide team then as well, and you fully deploy it organization-wide, that is the rough blueprint for an engineer-led MVP of AI into your organization then as well. And that's me. I have recently become one of those annoying YouTube people, so if you take the time and you'd like to hear about the cool things in the AI space and everything SRE, please subscribe to my channel. It's always greatly appreciated. You have me there on LinkedIn as well. I love to talk tech. I'll talk tech to anybody about anything. Thank you all for your time today. I've been Dan Murphy.